Welcome to the Explainer. Today we're digging into a rule that runs the entire universe. It explains everything from a log burning in a fireplace to a firework that just disappears. Let's jump in.
So think about it. You've got this huge, spectacular fireworks show. We're talking thousands of pounds of gunpowder lighting up the sky. And then, poof, it's gone. Just vanished. So where did it all go? Did it just get, erased from existence? Or is something else going on? That's the exact mystery we're going to solve. To get to the bottom of this fiery mystery, we have to become detectives. We're going to investigate how you can change matter, and that's just the sciencey word for all the physical stuff that makes up, well, everything.
Okay, so here's our game plan. There are basically 3 ways you can mess with matter. First, you can change it physically. Bend it, crush it, tear it. Second, you can change its state, like freezing liquid water into solid ice. And third, the really interesting one, is a chemical change, where you make something totally new. We're going to test all 3 to see if we can make matter actually disappear. All right, first up, let's just try reshaping something. If you squish it or pull it apart, does that change how much of it there is? In science, to be super precise, we talk about an object's mass, not its weight. So, will a physical change affect its mass? Let's find out. So for our first experiment, we've got a simple ball of blue modeling clay. We're going to pop it on a digital scale so we can get a really accurate measurement of its mass.
And there we go. The scale says 15.5 grams. Got it? Okay, remember that number.
Now for the physical change. I'm just going to use my hands and pull this one ball of clay into 2 smaller pieces. It's still clay, right? Just in a different shape.
And now for the moment of truth. Let's put both of those pieces back on the scale, and look at that. Still 15.5 grams. Exactly. So just changing its shape didn't make any of the matter vanish. Clue number 1.
Now this brings up a really critical idea in science, the closed system. It just means that we have to keep track of all the parts. With the clay, that was easy. But think about sawing a piece of wood. To have a true closed system, you'd have to catch every single tiny speck of sawdust. For our tests to be legit, nothing can get in or out.
Okay, physical change was a bust. So let's try changing the state of matter. For this, we'll use a sealed jar of water. By sealing the cap, we're creating our own little closed system.
Let's get our starting measurement. On the scale, the jar plus the water inside comes to 313.3 grams. Now we're going to stick this whole thing in the freezer overnight. We're changing the liquid water into a solid block of ice. It's still just water, H2O, just in a different state.
So the next morning, we take it out, put it back on the scale, and what do you think? Yep, still 313.3 grams. Not a single bit of mass has changed. A pattern is definitely emerging here.
So far, no luck. We can't seem to make matter disappear. But we've saved the most powerful test for last, the chemical change. This is what scientists call a chemical reaction. And this is where it gets really cool, because we're not just changing its shape or state, we're going to try to change what the stuff is actually made of.
A great way to think about a chemical reaction is baking cookies. Seriously, you start with your ingredients, flour, sugar, eggs. Scientists call those the reactants. Then you mix them up and bake them. That's the reaction. And what you get at the end is something totally new. Delicious cookies. Scientists call those the products.
And that's the huge difference, right? With a physical change, you end up with what you started with. Ice is still water. But with a chemical change, your starting stuff transforms into something brand new. You can't unbake a cookie and get your egg back.
So let's test it. We're going to drop an antacid tablet into vinegar inside a sealed bottle, our closed system. You can see it fizzing like crazy. That's a new gas being created. The tablet itself seems to just disappear. But what about the mass? Take a look. The mass of our system before the reaction and the mass after is identical. Even when we made a totally new substance, no mass was lost.
And this incredible discovery has a name. It's one of the most important rules in all of science, the law of conservation of mass. All it means is that, in a closed system, matter isn't created or destroyed. The mass is conserved, which is just a fancy way of saying it stays the same no matter what.
So let's circle all the way back to our fireworks.
Where did they go? Well, a firework exploding is a massive chemical reaction. That powder wasn't destroyed, it was chemically transformed into smoke, ash, and a whole bunch of different invisible gases. We can't see those gases, but they still have mass. If we could somehow trap all of that smoke and gas in a giant bubble, it would have the exact same mass as the fireworks before they were lit. It wasn't gone, it just changed.
Now, understanding a law is one thing, but really mastering it, getting a feel for it, that's where experimenting comes in. It's how you really make it stick. And you don't even need a physical lab to do it. These days, amazing learning tools can turn your screen into a kind of atomic playground, where you can mess with these ideas yourself.
For example, in some games, you might run a virtual factory, sorting different materials to really get the difference between them. In others, you might literally be building atoms piece by piece. And that's when you get to see why this law works at the deepest level.
Because here's the ultimate secret. A chemical reaction is just a cosmic rearrangement. It just takes the atoms you started with and shuffles them into new groups, new molecules. It never, ever creates new atoms or destroys old ones. And since you start and end with the exact same collection of atoms, the total mass has to be the same. The building blocks are all still there, just rearranged.
So the next time you watch a campfire burn down to ash, or a puddle evaporate after the rain, you will know the secret. Nothing was lost. It just changed its disguise. Which makes you wonder, doesn't it? If matter is never truly gone, what else is out there, all around us, just hiding in plain sight? Thanks for joining me on The Explainer.